Okay, so in previous videos, we talked about the player class, how it implements the mouse listener. We talked about all of the instance variables that each player keeps track of. The first group being the score for each category, the next one being the index for the individual player, and this last one being the dice that it will place, score and place, in a particular category at the appropriate time. The constructor that initializes all those variables, initializing all of the categories to -1, its index to the variable that it was given so that each player will know its own appropriate index, and all dice starting out at null. The scorecard is full, which is used by the game to know whether or not it's the end of the game or whether or not to skip a particular player because his scorecard is full and another player's scorecard might not be. The paint method, which draws all the appropriate scores in the appropriate places on the scorecard. Place dice, which is called by the game when it's the appropriate time for that player to place the dice on the scorecard. Get upper total and get lower total, which are used by the paint method to calculate the totals of the top and bottom half to go in the scorecard. I just mentioned what they are and talked a little bit about how they work, and I'll make another video that goes into a little bit more detail and shows some comments that describe in detail, because you will implement those. The mouse event methods, we talked about mouse pressed in detail, which will either ignore a click, or if it's the appropriate time and the click is in the appropriate place, call a method which will then look at the dice and determine what score to place in the appropriate section. Now, there are three what I'm going to call helper methods. One is called total all dice, which is really pretty easy. It just calculates the total of all the dice, because several of these things, like 3 of a kind, 4 of a kind, and chance, the score that is actually placed in that category is the sum of all the dice. So rather than writing that code multiple times, we'll write it in one method and then call it from each of those other 3 methods. So we don't have to write this code twice. That's why I call it a helper method. It just kind of helps out these other methods by splitting out the code. It's not just functional decomposition. It's not just making this method a little bit easier to think about, but it is also eliminating some redundant code, which is always a big win. GetDieCounts is a helper method, which we'll talk about in a good bit, probably in this video, because it needs to be used in place 3 of a kind. It's used in place in full house. It'll be used in place 4 of a kind when you write that. So this GetDieCounts is converting the dice to a different, it's converting the data into a different format. And then the end turn. Whenever they click in an appropriate section, we have to end the turn. And so nearly all of these methods, or maybe all of them, at the very end, we end the turn, because that player has placed the dice in a category. His turn is over. He's got to essentially let go of the dice, setting them to null, and then tell the game that, hey, I've placed my dice, you can go on to the next thing, and then tell the game to repaint. So end turn I've just described. Total all dice you will implement GetDieCounts. That's a little bit more complicated. Okay, so I'm going to illustrate what this GetDieCount method does via 6 examples. So I'm going to give you 6 examples, and you should be able to understand it reasonably easily that way. So we're going to assume for each example that the game has called this place dice method and has given an array of 5 dice to the player. So then the player's mouse press has been called, and it is placing the dice in one of these categories that calls getDieCounts. And so in my example, I have written all dice sub 0 dot get value equals 5. That's because the die that is placed in index 0 has a value of 5. And the one with a 1 has a 4, the one at index 2 has a 6, the one at index 3 has a 2, and the one at index 4 has a 2. Now suppose, after we've got those dice, we call the method getDieCounts and assign its return value to the variable dice count. So we've got this line of code being executed, and we had these dice passed into the player. So that's this line of code being executed. After that line of code is executed, this variable DieCounts, if you access the element at index 1 for this array, its value will be 0, because we do not have any dice with the value of 1. If you access index 2 of that array, you have the value of 2, because 2 of these dice have 2s. If you access the element at index 3, you'll get a 0, because there are no 3s. If you access index 4, you'll get a 1, because there's 1 4. If you access index 5, you'll get a 1, because there's 1 5. And at index 6, there's a 1, because there's 1 6. And likewise, if you were given this set of dice, all dice sub 0 dot get value equals 4, because dice at index 0 has a value of 4. You execute DieCounts. We have 1 1, we have 1 2, we have 1 3, we have 2 4s, no 5s and no 6s. So what this method is really doing is it's converting the information from an array of dice, each with a value, to an array of values that indicate how many dice had each of those values. Okay, so it's an array of indices where each index value tells you how many dice were of that value. So this is the dice value, and this is a count of how many dice, where this is a particular die, and then this would be its value. Now I've used the double equals to just say, to illustrate that this expression evaluates to a 4. So this is a Java code that evaluates to a true statement. Okay, so it doesn't really take 6 examples to really understand the gist of what getCounts is doing. And we can walk through the code, and we will in a second, to see how exactly it does that conversion. But there's a question that should probably be on your mind: why would I want to convert it to this? And the answer is that in this second format, certain things are much easier to calculate. And this is a common idea in programming. So the difference between learning Java and learning to be a good programmer is that, you know, if you're learning Java, you're just learning little details of the language. But when you learn to be a good programmer in any language, you're learning to think about your data structure and how you're storing your data. And if it's not convenient, is there a way to convert it to some other type that is more convenient for calculating what you want to calculate? So in our case, we're playing Yahtzee, and Yahtzee has things like 3 of a kind, 4 of a kind, small straight, and large straight. And if I'm looking at it in this kind of format where I've got 5 dice and I know their values, it becomes very difficult to figure out if I've got a small straight or a large straight or a 3 of a kind or a 4 of a kind. But if I look at it in the second format, those calculations become much easier. I can look, if I've got a 3 of a kind, I can look at this and I will have to have at least some number that is 3 or bigger. Nope, no 3 of a kinds. Nope, no 3 of a kind. Nope, no 3 of a kind. Here, I've got a 3 of a kind. I've got 3 ones. Yeah, sure enough. In the picture, I can see 3 ones. But of course, the computer doesn't see the picture. The computer sees this. For full house, you've got to have a 3 of a kind and a pair. And I've got a 3 and a 2. So if I have both a 3 and a 2, I know I've got a full house. Here, I see that I've got a 3 of a kind. Here, I don't. So the conversion is important. So now, for a small straight, I've got to have 4 numbers that are all grouped together. No, I've got a straight of 3, but not 4. Here's a small straight because all of these are clumped together. Here's a small straight because I've got a sequence of 4 non-zeros. I don't have a sequence of 4 of non-zeros. I don't have a sequence of 4 non-zeros. I don't have a sequence of 4 non-zeros. So that's the idea. Converted into this other format, it'll be easier for us to just sort of pass through this array of die counts and calculate what we want to calculate. So let's look at the code and see how this conversion takes place. So die counts. Not much code there. It's actually rather simple. We just declare an array. We create a variable that is an array of ints. We initialize it, able to hold 7 ints. Now we only need 6. We're just going to ignore the 0 spot because I really want to deal with indexes 1, 2, 3, 4, 5, and 6. So I just ignore index 0. And then for each die, in the all dice array, die count sub, so I'm going to go through each of the dice, store them in D one by one. I'm going to get its value, and I'm going to use that as the value, that value of that dice as an index into my dice counts, and I plus it. So how does this play out in our slide? So it's going to go through each of the dice one by one. When I first create this array, it's got zeros in every spot. Then I go through the dice. It's going to go first to die 5. D.getValue evaluates to 5. Plus is going to add 1. So dice count at 5, it's going to add 1. So imagine these were all zeros. This is going to go up to 1. And then it goes on to the next dice. And it's going to get the value. The value evaluates to 4, so the thing at index 4 is going to go up to a 1 from a 0. And then it's going to go to the next die, and that one's 6. So D.getValue evaluates to 6, and so the one at spot 6 is going to go from a 0 to a 1. And then it sees this die. It evaluates to 2, so that this index now becomes 2. And so the spot at index 2 goes from a 0 to a 1. And then it goes to the last die, and it also evaluates to 2, and so that 1 becomes a 2. Die count sub 1 never got incremented, so it stayed 0. This one got incremented twice, so it ended up as a 2. This got incremented 0 times because there weren't any 3s. And this 4s, 5s, and 6s each got incremented once. And then it returns its array of counts. And so then whenever we call the method, we get an array of ints. And we're just going to store that array of ints and use it later. So that's how getDieCounts works. It's going to be used in a bunch of methods. So place in 3 of kind. How does that work? How much time have we got in our video? Oh, I need to stop this. So I'm going to start a new video and go through place in 3 of a kind and hopefully place in full house and small straight and those in the next video.